So we're going to continue in section 8.7 about exponential and logarithmic equations. This is page 28 in your notes. And there are only 4 examples we're going to look at today, but these are going to be some tougher logarithmic equations. And the homework that you're going to do after that will include a lot of the same types of equations that you dealt with last time, just to get a little bit more practice with those, but you'll also see some of these new, harder types of logarithmic equations. So letter A, I'd like to solve the equation log base 3 of x minus 5 plus log base 3 of x plus 3 equals 2. Well, hopefully you remember from last time that we cannot deal with solving a logarithmic equation if there are 2 logarithms in there. We need to use our properties to turn those 2 logs into a single log. Remember that when we add logarithms, we multiply the stuff inside. So I'm going to multiply what's inside and say log base 3 of the product of x minus 5 times x plus 3. And that equals 2. Well, we need to go and actually multiply these 2 things together inside your logarithm. That means in this case, you need to FOIL. We're going to get log base 3 of x squared minus 5x plus 3x minus 15 equals 2. And I can simplify that to log base 3 of x squared minus 2x minus 15 equals 2. Now, we'll do what we did last time. I have an equation in logarithmic form. I need to go and rewrite this in exponential form. I'm going to say 3 raised to the second equals the thing inside your log. So 3 to the second equals x squared minus 2x minus 15, or 9, equals x squared minus 2x minus 15. This is looking like a quadratic equation, so I need to make this equal 0. I'm going to go and subtract 9 from both sides. Minus 9 minus 9. 0 equals x squared minus 2x minus 24. We can solve this thing by factoring. If we couldn't, we'd have to use the quadratic formula, but this is factorable. I'm going to get 0 equals x minus 6 times x plus 4, which means x is going to equal either 6 or negative 4. However, we're not quite done. In the last 2 units that we looked at, sometimes our equations had those extraneous solutions, and that's happening here as well. Whenever we get a quadratic equation inside of a logarithm after using our properties, we're going to need to check for extraneous solutions. And for our purposes, this is the only time we're going to have to bother with this checking. When we get a quadratic equation, inside of a quadratic expression inside of a logarithm, solve, and we get a quadratic equation and solve that, we must then check for extraneous solutions. And hopefully remember that an extraneous solution is a sort of solution that arises from our work, but if you go to actually plug it in, it doesn't actually work. When we saw these with our square roots, we had to actually plug into both sides to make sure both sides truly were equal. When we saw these with our rational equations, we just had to make sure that our answer didn't make any denominators equal 0. Well, here, what we have to check for is make sure that we don't have any negative numbers inside of a logarithm. If I ask you, for example, to do the problem log base 2 of negative 4, that's asking us 2 to what power gives you negative 4? Well, if you think about it for a little while and can't get anywhere, go to your calculator, type in, use your change of base formula, log negative 4 divided by log 2, but that's going to give you a problem. We cannot have negative numbers inside of a logarithm. We are not allowed to have negative numbers inside a log. So what this means is I just need to make sure that if I went and plugged in 6 and then went and plugged in -4 to the original equation, I wouldn't get any negatives inside a log. I'm actually going to write out the plugging in check here, but I feel like in future problems you can just look at it and deal with it from there. If you go to plug in 6, I'm going to get log base 3 of 6 minus 5 plus log base 3 of 6 plus 3, which will maybe equal 2. I've got a positive number inside this log, 1. Positive number inside this log, 9. Yep, it's going to work. If you go and plug in x equals -4, you're going to get log base 3 of -4 minus 5 plus log base 3 of -4 plus 3. I want to see if that equals 2. Well, I've got a negative inside this log. I actually have a negative inside both logs. I've got 2 issues there. You only need to have a negative inside one logarithm for it to be an extraneous solution. But -4, nope, that's not going to work because, again, we're getting a negative number inside of our logarithm. I'm going to end this problem by saying the answer is x equals 6, and -4 is extraneous. It's important to realize that -4 is extraneous not because the answer itself is a negative number, but because when you plugged it in to a logarithm, you got a negative inside your log. If this problem over here was like -4 plus 5, that would be totally okay. You wouldn't be left with a negative number inside of a log. Our issue was that plugging it in gave us a negative inside that log. Take a look at letter B and see if you can get your quadratic equation out of that. And then I want to go through the solving bit with you. Adding these 2 logs, so I'm going to go and multiply the stuff inside. Go and distribute the x. Time to go into exponential form. So 5 to the 2nd equals x squared plus 2x. Should be able to get the quadratic equation x squared plus 2x minus 25 equals 0. Here's the problem. Go to factor this thing, it's not factorable, so we need to use the quadratic formula on this. I'm going to get x equals -b -2 plus or minus the square root of b squared, 2 squared, minus 4 times 1 times -25 all over 2 times 1. -2 plus or minus the square root of 4. Your double negatives there are going to make this into a plus, so plus 100 divided by 2. And we're going to get -2 plus or minus square root of 104 divided by 2. Now at this point, I actually want to get decimal answers for these. Because of the whole plugging in and checking for extraneous solutions, it would be a pain to try to plug in -2 plus root 104 divided by 2. We're going to instead get a decimal answer and then look and try to plug those in and make sure we don't end up with a negative inside any logarithm. We've seen these the decimals with these things before. What you need to do on the calculator is go and type in -2 plus the square root of 104. Push enter, get an answer, and then divide that answer by 2. So -2 plus the square root of 104, I'm getting 8.198. Then I'm going to go divide that by 2, and I'm getting 4.099. Go do it again now, but choosing the minus version of this, so do -2 minus the square root of 104. Push enter, get an answer. Divide that by 2, and you're going to get -6.099. as the two possibilities. If you go and plug in 4.099, add 2 to that, you're going to get a positive number inside the logarithm. If you just plug in 4.099 as is over here, you've got a positive number inside that logarithm. So that one's good. Plug in negative 6.099, add 2 to that. No, you've got a negative inside your logarithm. And actually, if you plug it in over here, you're also going to have a negative inside your logarithm. That one doesn't work. So I'm going to say that my answer is x is approximately 4.099. And I'm going to say that negative 6.099 is extraneous. Whenever we end up getting a quadratic equation, we're going to have to check for extraneous solutions. Because of the check, if we have to use the quadratic formula, give me a decimal answer. Again, let's stick to rounding to 3 decimal places, just because it's going to make it easier for us to plug in and check if those decimals are extraneous. 2 more examples that we need to look at. Letter C is a little bit different because instead of adding our logarithms, we're subtracting the logarithms. Hopefully you remember from our properties that when we subtract 2 logarithms, we divide the stuff inside. This is going to give us log base 2 of x over x minus 3 equals 5. Log base 2 of x over x minus 3 equals 5. I'm going to go now and convert this to exponential form. And I'm going to say 2 raised to the 5th equals that whole thing that I had inside. So 2 to the 5th equals x over x minus 3, or 32 equals x over x minus 3. This is one of our rational equations. I think the easiest way to proceed from here is to turn the 32 into a 32 over 1, and then we can just cross multiply, as long as we're careful with some parentheses. I'm going to say 32 times x minus 3, that's 32 times x minus 3, equals 1 times x. Can clean this up into 32x minus 32 times 3 is 96 equals x. Then just some simple algebra to solve this. Minus 32x from both sides. Negative 96 equals negative 31 over 31x. Divide both sides by negative 31. Here, because we can give an exact answer, let's give an exact answer than giving a decimal rounded on the calculator. And I'm going to say x equals 96 over 31. We are not going to have to bother checking these. But if we did check 96 over 31, that's positive, so that's okay. 96 over 31 minus 3, we'll go to the calculator and check that. It's a very small positive number, but it is a positive number, so yeah, it's good. The only ones we're really going to have to check, though, are the ones that give us a quadratic equation. I don't think there's anything new in letter D, so you try letter D on your own as I start to work through things. Either pause the video or just kind of tune things out and compare your work when you're done and see what happens. should be getting x equals 245 over 242. And that's it for this section. The homework is, let me find that and write that over here. The homework you're going to take a look at, page 52, 6 through 38, even. The beginning problems are more of what you did last time, just to get a little bit more practice with those exponential and logarithmic equations. And then the last few will involve problems like what we looked at today, where you have to use the properties and either get a quadratic equation or get a rational equation and have to solve those.